Hello everyone. Today we are going to analyze this frame using portal frame method. This is a single bay and a two-story frame. In this frame we have two lateral point loads, 20 kN in the point E and 10 kN in the point C. Let us see the assumptions in the portal frame method. Point of contraflexure occurs at the middle of all of the members of the frame. For each story of the frame, the interior columns will take twice as much shear force as the exterior columns. But in this frame, we have only exterior columns. There is no interior column. In this case, both of these columns will take the same shear force. In both of the stories, let us name the center of the columns as I, J, G and H. Let us split the frame into two parts. From the center of the columns in the top story, let us take the upper part. Let us keep the shear force as P. We know that both of these columns will take the same shear force, so P and P. Let us apply the rule sigma h is equal to 0. Both of these forces are acting towards the left side, so both of them are negative. This load is acting towards the right side, so that is positive. Finally, for P, we are getting 10. We have calculated the shear forces at just above the center of the columns. Below the center of the columns, they will be acting in the opposite direction. Now let us split the frame into two parts. From the center of the columns in the bottom story, let us take the upper part. Now let us apply this rule. Both of these forces are acting towards the left side, so both of them are negative. These two loads are acting towards the right side, so both of them are positive. Finally, for P, we are getting 15. Let us apply that. Now, using these shear forces, we can find the moments. First, let us find the moments in the columns. For that, we can use one formula, WL upon 2. First, let us take the member EC. Here, W is 10, L is 4. When we apply the values inside the formula, we are getting MEC and MCE. Now let us take the member FD. Here W is 10, L is 4. When we apply the values in the formula, we are getting MFD and MDF. Now let us take the member CA. Here W is 15, L is 4. When we apply the values in the formula, we are getting MCA and MAC. Now let us take the member DB. Here W is 15, L is 4. When we apply the values in the formula, we are getting MDB and MBD. Now let us find the moments in the beams. First, let us take the beam EF. If this moment is 20, MEF and MFE also should be 20. Now let us take the beam CD. We can find MCD and MDC by adding these two movements. When we do that, we are getting 50. In this analysis, we have calculated all of the movements. We have calculated the shear forces in the columns. Now let us find the shear forces in the beams. First, let us find the shear force in the beam EF. For that, we have to add these two movements, so 20 plus 20, and then divide by the length 5. When we do that, we will get 8. Now let us find the shear force in the beam CD. Here we have to add these movements, so 50 plus 50, and then we have to divide by the length 5. When we do that, we will get 20. So in this analysis, we have calculated the shear forces in the columns and beams. Now using these shear forces, we can find the axial forces. The axial forces in the beams will be compressive. In both of the stories, in the first column, let us assume that the axial force is tensile, and in the right side column, it is compressive. If we get any negative value, we can change the direction later. First, let us take the joint E. Let us keep the unknown horizontal axial force as H and unknown vertical axial force as V. Let us apply the rule sigma H is equal to 0. 20 is acting towards the right side, so that will be positive. These two forces are acting towards the left side, so both of them will be negative. Finally, for H, we are getting 10. Now, let us apply the rule sigma V is equal to 0. This force is acting upwards, so that will be positive. This force is acting downwards, so that will be negative. Finally, for V, we are getting 8. Let us apply both of the axial forces. Now, let us take the joint F. Let us apply this rule and find V. This force is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. Finally, for V, we are getting 8. Let us apply that. Now, let us take the joint C. Let us apply this rule and find V. This force and this force are acting upwards, so both of them are positive. This force is acting downwards, so that will be negative. Finally, for V, we are getting 28. Let us apply this rule and find H. 10 and this 10 are acting towards the right side, so both of them are positive. H and 15 are acting towards the left side, so both of them are negative. Finally, for H, we are getting 5. Let us apply both of them. Now, let us take the joint D. Let us apply this rule and find V. Both of these forces are acting downwards, so both of them are negative. V is acting upwards, so that will be positive. Finally, for V, we are getting 28. Let us apply that. We have calculated all of the axial forces. Now, using the moments, we can draw the bending moment diagram. Now, we are going to end this session. Thank you for watching this video.